simplified equation along with the methodology of continuous wave Doppler was introduced in this country, and various centers in this country, including our own group at Mayo, embarked on many validation studies for confirmation of simplified Bernoulli equation, derived valve gradients and valve areas, volumetric flow determination, intracardiac pressure determinations, as well as diastolic filling parameters. Let me now share with you a few examples of these correlative studies of Doppler catheterization conducted at our own institution. This first example is of a patient with aortic stenosis who is undergoing cardiac catheterization and simultaneous Doppler recordings in a remote called Mayo. You can see on the right side of the slide that the catheter gradient is 34 millimeters mercury and in the correlation study published by Dr. Curry from June 1985, showed excellent correlation between the Doppler-derived mean gradient and catheter-derived mean gradients. Turning our attention to the right-sided obstruction, here's an example of severe right ventricular outflow obstruction. On the top, right ventricular and pulmonary artery pressures are simultaneously recorded along with Doppler trace shown at the bottom. Again, excellent beat-to-beat correlation between gradients can be seen, and you can note that the maximum gradient by catheter technique is 86 millimeters mercury and by Doppler 90 millimeters mercury. In the correlation study published from our institution again over 10 years ago between the Doppler and catheter data, excellent correlation between the Doppler and catheter-derived gradients can be again demonstrated here. In patients with mitral stenosis, many institutions have demonstrated excellent correlation between the catheter and Doppler-derived mean gradients. In this example, on the left screen, you can see pulmonary capillary wedge-derived mitral gradient matches fairly nicely with Doppler-derived gradient of 8 millimeters mercury. On the right half of this panel, you can see direct left atrial pressure derived mitral gradient of 9 millimeters mercury, which also correlates excellently with Doppler-derived gradient of 8 millimeters mercury. However, Dr. Nishimura in our group has noted marked discrepancy in selected cases of mitral stenosis when the catheter-derived gradient was being measured by pulmonary capillary wedge technique. As shown in the left-sided panel here, the catheter-derived gradient by pulmonary capillary wedge technique is 17 millimeters mercury, while Doppler-derived gradient is only 9 millimeters mercury. The overestimated gradient persisted even after correcting for the pressure delay in transmission. On the right side of the screen here, you can note that when the transeptal catheterization is performed and direct left atrial pressure is being recorded, that the gradient by catheter matches very closely by that from Doppler technique of 8 millimeters mercury. So in the correlation study that was published by Dr. Nishimura approximately 3 years ago, you'll note in the left-sided panel excellent correlation between Doppler-derived mean gradient and direct left atrial and left ventricular pressure gradient as they were measured. But on the right side panel, you'll see that when pulmonary capillary wedge pressure is used as a surrogate for left atrial pressure, that in many cases, significant overestimation of Doppler gradient, of catheter gradient was present when compared to Doppler gradient. So we can summarize from this study that currently Doppler technique can be utilized as the standard of measurement for gradient measurement in patients with native or prosthetic mitral stenosis. Now let's move on to the next subject, which is determination of intracardiac pressures. This is based upon recording the peak velocity of the regurgitant jet. As shown in the slide, we have schematically demonstrated various regurgitant jets from different valves. In practice, in routine practice, we use tricuspid regurgitant jet velocity for measurement of right-sided pressures. Dr. Sharon Hayes will be elaborating on this further in her presentation. As shown on this slide is a correlation study published from our own institution by Dr. Curry when he was here in mid-1980s, showing again excellent correlation between Doppler-derived and catheter-derived right ventricular systolic pressures. The next and also very important measurement in the in the echo laboratory is measurement of the volumetric flow. Dr. Gura will be elaborating on this further in his presentation, but volumetric flow determination is based on a simple hydraulic formula of obtaining the stroke volume utilizing the area multiplied by the time velocity integral. This concept can be applied to any orifice in our cardiovascular system. In routine practice in our own labs, we use aortic annulus for diameter measurement, and time velocity integral is obtained there for routine stroke volume and cardiac output measurements. The same concept can be applied to the mitral orifice region to obtain volumetric flow entering into left ventricle. These concepts then can be translated to measurement of cardiac output, regurgitated volume, and shunt volume. And Dr. Seward and Dr. O'Leary will be elaborating on this further in their presentations. We are also utilizing Doppler for assessment of ventricular function, both systolic as well as diastolic. And as Dr. Seward mentioned, in our third segment, we'll be concentrating upon the utility of Doppler for diastolic function assessment using E and A velocity, E over A ratio, and isovolumic relaxation time, as well as refer to the time constant